Welcome to lesson 5-2, measurement of rotation. The objective here is that given an angle of any measure, draw a picture of that angle. Okay, so we're going to define an angle as a starting point in this topic. So our topic is measurement of rotation. And when you say measurement of rotation, it involves circular and angular rotations. Am I correct? So we are to define what first is rotation and what an angle is. Now in geometry, you actually learned about angles, right? And an angle is defined by two rays intersecting at a common point, which is what we call the vertex. So the vertex here is here, and this is the point of intersection, right? So this is the vertex. And this vertex is the point of intersection. So this is the point of intersection of your two rays. Okay? And what are those rays? Let's call the first ray as A. So this is ray 1 or ray A. This is ray B. And what is a ray? A ray is composed of a point at one end and an arrow on the other end. So a point at one end and an arrow on the other end. So we have two rays here, and they converge at one point, which is called the vertex, and therefore they form an angle, right? So what is the angle there? Now this vertex that I'm trying to emphasize here is a fixed point. It is fixed, because if it's not fixed, then the angle would not be fixed also. Okay? So what I'm trying to say is, when this is not a fixed point, this will pass through the other, what do you call this? The other ray. Okay? And that gives the angular deviations. It gives angular deviations, although the angle here remains the same. When you measure the angle here, it will remain the same. But the thing here is, it deviates from its original length. The length of this sides deviates from the original length, and therefore creating, if there's another, if there's a significant, let's say, shape there or other things in geometry, then that would be a tremendous mistake. Okay, so therefore the vertex, or also known as the fixed point, should be fixed. Okay, so this intersection produces an angle, and this angle is this. And normally the angle is defined by theta. Okay, this is the angle between the two rays. Okay? So where is your initial point and where is the terminal point? That's another question. This is our initial point, or initial side, let's say. Okay, initial side. Because this is where the angle came from. Take note, our angle forms an arrow at the head, and it came from here and going there, meaning its heading is through here. Okay? It won't be coming here because the arrow is going there. So this is the initial side, and this is where the angle terminates. It's what we call the terminal side, or the side B. Okay? So in other words, you call the initial side as initial position. It's also called initial position. And this is a terminal position. Okay? So this is the angle theta the theta that you see in between those two rays. And this is a rotating ray. Okay? So given that you have a fixed point here, the idea here is that given that fixed point, okay, this angle here will vary. Okay? This will change or vary because this ray is rotating. Okay? This ray would go here. If given the chance, it would go here. Okay, so this is the position of your ray. So this is B, and now this is B. So it has rotated, and now you have some definite angle also. So this is theta plus another angle. Let's say beta. Okay, so where is beta? Beta is here. Okay, and beta is also a Greek letter, so B is beta. Now, most of the Greek letters define the angles and densities, these terminologies in mathematics and physics are all defined by famous, Greek alphabets. Okay? So, what is the definition of the standard position of an angle? So, according to our book, an angle is in a standard form in a Cartesian coordinate system. So it's in a standard form in a Cartesian coordinate system. What is the Cartesian coordinate system? That is the system with x and y. That is our Cartesian coordinate system. Okay, so an angle is in a standard position in a Cartesian coordinate system if, number one, its vertex is at the origin. Okay? Meaning the vertex of the angle should come from the origin. So it should be from here. This is when the standard position of an angle is defined. Its initial side is along the positive horizontal axis. Okay, let's draw a more decent Cartesian plane. Okay, so let us have this and this. Okay. So according to this standard position definition, first is the angle is in standard position when the point or the origin or the vertex is at the origin. So that's the vertex. Okay, this is the vertex. Next is when the initial side is along the positive horizontal axis. So where is the positive horizontal axis? This is here. Okay, so let us tap that with a light green. So this is the initial side. It is measured counterclockwise from the horizontal axis if the angle measure is positive, and clockwise if the angle measure is negative. So the angular measure always begins from this side. So meaning it's counterclockwise if the angular measure is positive. So when theta is greater than 0, then our rotation direction is counterclockwise. This is counterclockwise, right? It's opposite the clock, so it's called counterclockwise. Now, if your theta is less than 0, then we will still begin from this initial side or initial position, going to the terminal side or terminal position. But this is when your theta is negative. What are negative? So example of theta negative is theta equals negative 30 degrees. Okay, which is somewhat here. So this is negative 30 degrees. Okay, when your theta is positive, so theta is equal to 60 degrees. For instance, this would be somewhat here. Okay, this is positive theta, 60 degrees. Okay, so I think that's a little bit of understandable now. So to have a more, what do you call this, a more explicit definition. Okay, so we're going to show the placements of the rotating ray. Let's call the point of, or the terminal point, okay, as a UV, and we take this in a UV. So this is, we have defined a UV axis. This is our V, this stands for our Y, and this is U, this is our initial side, or the x-axis. So UV. So this is a UV coordinate system. Okay? This is similar to the Cartesian coordinate system, just that we changed the variables of our axis into U and V. So we have this. Now look at the first example. So the first example, we should start from the origin. That's the standard position definition. Okay? And then we start the measure of the angle from the positive horizontal x-axis. So this is like that. The measure of this angle is 57 degrees, just to be clear, because it is somewhat cloudy in here. You cannot read it. So this is positive 57 degrees. Now taking the angle further to the left will give us an angular measure which is greater than 90. Okay, starting again with the origin. So this is our starting point, because that's our center, and that's the vertex. Okay, then if we are going to take the angle, so note that this is greater than 90 degrees. But still, because it is its rotation should start from the initial side, which is the along the positive x-axis, then this would be measured in a counterclockwise position, and this is equivalent to 135 degrees. Okay, what happens when we start getting the angle from a clockwise direction? So what happens is, this is our angle, okay? And we are going to get the angular value from a clockwise direction. And a clockwise direction implies that the angle is negative. So this is, in this case, negative 251 degrees. It's not yet 270 degrees, but it's reaching it. Okay? Now, let us take a look at this example. And this example came from the positive x-axis, going through one revolution and another angular value. But still, it is positive because it is on a counterclockwise direction. So look at that. And the value of this angle, the measure of this angle, is actually 560 degrees. So this is 560 degrees. Why 560 degrees? We have one complete circle. This one complete circle is this, and that's 360 degrees. And we measure this angular excess here as 120 or 100 degrees. Is it 100 degrees? No, it's 190, 200 degrees, okay? So that's 200 degrees. So therefore, this is 560 degrees. Okay? Next, we have another term here, which is called the coterminal angles. So what are coterminal angles? Well, coterminal angles are angles which have or which whose terminal side ends up at the same point. So those are coterminal angles. Okay, so let us take a look at all of these examples above. The first angle is 133 degrees, right? So let us take a look at 133 degrees. Our theta here is 133 degrees. Now, how do we look for a coterminal of this 133 degrees? So, if this is our given, then we could find one coterminal by applying and ending up to the same terminal side. That is why it's called coterminal, because they end up at the same side. So in this case, we have one complete circle, which is defined by this, and we have another 133 degrees. So the coterminal of 133 degrees, so let's say cot, okay, would be this 360 here, the one in indigo or violet or purple, okay, plus 133 degrees. So that gives us a value which is, what is this? This is 493 degrees. Okay, that's one coterminal. Now another coterminal could be coming from the negative or from the clockwise going there. So what is that coterminal? Okay, now we can find that by subtracting 360. Notice that if we continue this red line up to here, that would give us a complete circle, and that's 360 degrees. So all we need to do is, so this is one, theta cot 2, let's say, okay, we'll have, this is actually 360 degrees minus 133 degrees. Am I correct? So that would be 360 degrees minus 133 degrees would give us another coterminal, which is 360 degrees minus 133 degrees. That's 227 degrees. But should it be positive? Look, we got it into a clockwise direction. So the sign for this angle is negative, right? So that's the coterminal. So 133 degrees has two coterminals, and these coterminals are given here. So we have 493 degrees and also negative 227 degrees. Okay, now there are other coterminals there. We can extend this 227 degrees up to, another rounds. It could be like that. So negative 360 minus 227, or negative 360. So if we do it from here, that's negative 360. Okay, negative 360 and then another 227. So we could also get 587, negative 587 degrees as one of the coterminals. So you could have infinite coterminals with our 133 degrees. So what is the definition of coterminal angles? Coterminal angles are two angles in standard position if and only if their degree measures differ by a multiple of 360 degrees. So take note, we always have 360 degrees there. Okay? So if and only if their degree measures differ by a multiple of 360 degrees. So there is phi, so this one is called phi. So this is also a Greek letter, so this is called phi. Okay, or similar to the pronunciation of physics, so phi. Okay, but the spelling is phi. Okay, and theta are coterminal if and only if phi is equal to theta plus n times 360 degrees, where n stands for an integer. So n could be negative if the rotation came from a counterclockwise direction, your n is negative. If it came from, or if it comes from a clockwise, I'm sorry, if it, I think I'm confused. If it came from, if the rotation that you took came from a clockwise direction, it's negative, and it will be positive. The direction is counterclockwise. Okay. So coterminal angles have terminal sides that coincide. Okay, here's the name. That's why I told you. That's what I told you a while ago. Okay, so we have another concept here, the concept of reference angle. So what is a reference angle? A reference angle, by definition, the reference angle of an angle in standard position. Remember, a standard position, the vertex is in the origin, okay, and the terminal side is along the horizontal, positive horizontal x-axis. So the reference angle of an angle in standard position is the positive acute angle. The positive acute angle between the horizontal axis and the terminal side. So what does it mean? Okay. A reference angle, take note, is the positive acute angle between the horizontal axis and the terminal side. So let's consider an angle. Let's draw a Cartesian axis. Okay. Let's draw an angle. What if my angle is here? Okay. And that angle would give me so it would give me something like that. And what if this angle measure here is let's say 133 degrees. Okay, so let's say theta is equal to 133 degrees because this is greater than 90, and that's how I envision it to be 130 degrees. So the terminal angle, or the reference angle rather, is the angle, the positive acute angle. And remember that an angle is positive. The angle is positive if it starts from a horizontal, or from a counterclockwise direction. Therefore, the reference angle of this would be here, up to here. Am I correct? We couldn't get this one to here because that would give us a negative, or a clockwise direction, which is negative. Okay, and it couldn't be reference, or theta ref. Let's call it theta reference, or reference angle. So in this case, our reference angle is equal to, that would be measurable by, remember this is 180 degrees, right? So that 180 degrees minus 133 degrees would be your reference angle. And what is the answer here? We have 47 degrees. So remember, it's always positive. Okay? So let's take another example. So this is my x and y coordinate. And let's say my angle is, let's say, more than 270. Let's say 310 degrees. Okay? So my theta here, let's say my theta is 315 degrees. Okay? So that would give us something like that. Okay? So therefore my reference angle would be from here going to here. So this is my theta ref, and my theta ref is equal to, how do you compute for that? We have 360 degrees minus 315 degrees. So that's 45 degrees. Okay, we cannot use it like from here to here because it's negative 45 degrees. So in rotation, angle rotation, the direction of the angle, say this arrow, okay, is very important because that will also affect the sign of your angle. So in this case, our theta ref, or our reference angle, is always positive. So this is about reference angles. So again, I hope you enjoyed the explanation on this lesson. And for the next videos, we're going to do more examples for reference angles and coterminal angles. So thank you for watching.